In the previous video, we discussed regarding structure of human respiratory system or anatomy of human respiratory system. In continuation with that, in this video, we learn about mechanism of breathing or process of breathing. You all know that breathing takes place mainly by two stages or two steps. That is inspiration, which is also called as inhalation, and expiration, which is also called as exhalation. And you know the meaning of this term also. Inspiration or inhalation is nothing but breathing in, or it's a process in which atmospheric air is taken into the lung, whereas the expiration or exhalation is breathing out, or it's a process in which the alveolar air, that is air present inside the lung, is expelled out or thrown out of the lung into the atmosphere. So this process of movement of air in and out of the lung is known as breathing or respiration. On an average, a healthy humans will breathe of about 12 to 16 times per minute. So the movement of air in and out of the lung is nothing but the respiration or breathing. But how this air moves or gas moves? You know that generally gas or air moves through simple diffusion, and for the diffusion there should be pressure gradient. Pressure gradient means difference in the pressure. So when there is a difference in the pressure, air moves from a region of high pressure to a region of low pressure by simple diffusion. Same mechanism occurs even in the respiration. So air moves in and out of the lung through this pressure gradient by simple diffusion. But who will create this pressure gradient or difference in the pressure? It is with the help of a respiratory muscle. So this respiratory muscle helps in the creation of this pressure gradient. Pressure gradient between what? Between the atmosphere and the lung, which is also known as atmospheric pressure and intrapulmonary pressure. So there should be creation of pressure gradient between the atmosphere and the lung, and it is created with the help of set of muscle known as respiratory muscle. Respiratory muscle mainly includes two types of muscle, that is diaphragm and external internal intercostal muscle. So these are the two set of muscle which helps in the creation of pressure gradient. We'll discuss it one by one. First one is diaphragm. So diaphragm is a dome shaped muscle that is present at the lower side of the lung. So at the lower side of the lung you can see a dome shaped muscle known as a diaphragm, or diaphragm is the one which separates the thoracic cavity and the abdominal cavity. So that is about the diaphragm. Second set of muscle is external internal intercostal muscle. So it's a set of muscle that is present between the ribs. You know that ribs are present onto the lateral side of the lungs, and between these two ribs, these external internal intercostal muscles are extended. So these muscles are stretched diagonally between the ribs, and these muscles are known as external internal intercostal muscle, which are stretched diagonally between the ribs. So these are the two sets of muscle known as respiratory muscle, which helps in the creation of pressure gradient between the atmosphere and the lungs, or the intrapulmonary pressure. But how exactly these two set of muscle creates a pressure? Yes, it is by contraction and relaxation of this muscle. So upon contraction and relaxation of the muscles of diaphragm and external internal intercostal muscle, there will be increase or decrease in the thoracic cavity. So there is an increase or decrease in the volume of the thoracic cavity. In turn, it is related to the pressure of the thoracic cavity. You know how volume is related to pressure, isn't it? It's inversely proportional. So when there is an increase in the volume, there will be decrease in the pressure. When there is a decrease in the volume, there will be increase in the pressure. So it is inversely proportional. So when there is a contraction and relaxation of these muscle, there will be increase or decrease in the volume of the thoracic cavity. In turn, there will be increase or decrease in the pressure of the thoracic cavity. And you know how this volume and pressure is related, or relationship between the volume and the pressure. So there will be decrease or increase in the pressure of the thoracic cavity or the volume of the thoracic cavity. In turn, this change in the thoracic cavity is related to the lung cavity or the pulmonary cavity. But how this thoracic cavity and the pulmonary cavity is related? Before that, we'll see the difference between the thoracic cavity and the pulmonary cavity. So volume of the thoracic cavity means it's a cavity that is present in the thoracic region, which includes heart, lung and all other spaces. So that is nothing but the thoracic cavity, and whatever the air that is present inside this thoracic cavity is nothing but the volume of the thoracic cavity. Whereas the pulmonary cavity or the lung cavity is nothing but the cavity that is present inside this lung, and the volume of this pulmonary cavity or the pulmonary volume or the lung volume is nothing but the volume of the air that is present inside this lung is nothing but the pulmonary volume or the lung volume. So thoracic cavity means cavity that is present inside the thoracic region, that is which consisting of heart, lung and the other cavity. So volume means volume of air that is present in the thoracic cavity, whereas lung cavity or the pulmonary cavity means cavity that is present inside the lung, and the volume means amount of air that is present inside this lung is nothing but the lung volume or the pulmonary volume. So this volume of the thoracic cavity is related to the pulmonary volume. But how it is related? Yes, it is because thoracic cavity is an airtight chamber. Airtight chamber means air cannot move out or in easily. So air can't move out or in from the outside. That's why it is called as airtight cavity, and it is created by the presence of different structure around the thoracic cavity. For example, from the dorsal side, this thoracic cavity is guarded by the vertebral column, or vertebral column is present on the dorsal side, whereas on the ventral side, sternum is present. On the other hand, onto the lateral side, ribs are present, and at the lower side, diaphragm is present. So all these structure makes a thoracic cavity as an airtight chamber. So because of this airtight chamber of the thoracic cavity, or the nature of this thoracic cavity, if there is any change in the thoracic cavity, it will be related or it will be shown even in the pulmonary cavity or the lung cavity. For example, if there is increase in the volume of the thoracic cavity, obviously there will be increase in the volume of the pulmonary cavity or the pulmonary volume. So if there is decrease in the volume of the thoracic cavity, there will be decrease in the volume of the pulmonary cavity also. Similarly, if there is increase in the pressure of the thoracic cavity, there will be increase in the pressure of the pulmonary cavity. If there is a decrease in the pressure of the thoracic cavity, there will be decrease in the pressure of the pulmonary cavity. So that is how it is related. It is directly proportional, and it is because of the airtight nature of the thoracic cavity. So if there is any change in the volume of the thoracic cavity, it will be reflected in the pulmonary cavity, volume of the pulmonary cavity or the lung cavity. So that is how it is related. So when there is an increase or decrease in the volume or pressure of the thoracic cavity, it will be reflected in the pulmonary cavity. So there will be increase or decrease in the pressure or volume of even the pulmonary cavity. You can tell that it is directly proportional. So that is how thoracic cavity is related to pulmonary cavity, and it is because of the airtight nature of the thoracic chamber. And it is because of the airtight nature of this thoracic chamber actually respiration takes place. Now we'll learn how exactly respiration takes place, or we'll learn these two steps in detail, that is inspiration and expiration. First we'll learn about the first step, that is inspiration, which is also known as inhalation. Inspiration or inhalation takes place when the intrapulmonary pressure, that is pressure inside the lung, is way less when compared to atmospheric pressure, or when there is a negative pressure inside the lung, inhalation or inspiration takes place. And this inhalation begins with the contraction of diaphragm and external intercostal muscle. So when there is a contraction of dome-shaped diaphragm, this dome-shaped diaphragm will descend and it will become flat or horizontal. So dome-shaped diaphragm, when it contracts, it will descend and it will become flat. So when this diaphragm descend, there will be increase in the volume of the thoracic cavity in the anterior posterior axis. So when there is a contraction of diaphragm, the diaphragm descends. Because of that, the pulmonary cavity or the volume of the pulmonary cavity increases in the anterior posterior axis. Similarly, when there is a contraction of external intercostal muscle which are present between the ribs, what happens? These ribs move upward and outward. So because of that, there will be increase in the volume of the thoracic cavity in the dorsoventral axis. So when there is a contraction of diaphragm, there is an increase in the volume in anterior posterior axis, and when there is a contraction of external intercostal muscle, the ribs will move upward and outward, because of which the volume of the thoracic cavity increases in the dorsoventral axis. So because of the contraction of both the muscle, that is diaphragm and the external intercostal muscle, there will be increase in the volume of the thoracic cavity both in the anterior posterior axis as well as the dorsoventral axis. So there is an increase in the volume of the thoracic cavity. When there is an increase in the volume, obviously there will be increase in the pulmonary cavity. And what happens to pressure? Pressure decreases because it is inversely proportional. So when there is an increase in the pulmonary volume, there will be decrease in the intrapulmonary pressure. So when compared to atmospheric pressure, intrapulmonary pressure decreases, or negative pressure is created inside the lung, because of which air moves from outside to inside, that is from atmosphere to lung. So atmospheric air enter the lung, or inhalation takes place. So that is how exactly inhalation takes place. Second step is expiration or exhalation. Expiration or exhalation takes place when the intrapulmonary pressure, that is pressure inside the lung, becomes more when compared to the atmospheric pressure, and this happens when there is a relaxation of these muscles, that is when there is a relaxation of diaphragm and the intercostal muscle, the intrapulmonary pressure increases when compared to the atmospheric pressure. So when the diaphragm relaxes, so diaphragm was flat or horizontal during the inhalation. So when this diaphragm relaxes, it regains its original shape, that is dome shape. So diaphragm becomes dome shaped. Because of that, there is a decrease in the volume of the thoracic cavity in the anterior posterior axis. Similarly, when there is a relaxation of intercostal muscle, what happens? These ribs moves downward and inward. So because of that, there is a decrease in the volume of the thoracic cavity even in the dorsoventral axis. So because of the relaxation of these two muscles, there is a decrease in the volume of the thoracic cavity. In turn, there is an increase in the pressure of the thoracic cavity. So when there is a increase in the pressure of thoracic cavity, obviously there will be increase in the intrapulmonary pressure when compared to atmospheric pressure. So there is a slight increase in the intrapulmonary pressure when compared to atmospheric pressure. So because of that, air moves from the lungs to outside. So from the region of high pressure to the region of low pressure, that is from the lung the air moves to outside, which is nothing but expiration or exhalation. So that is how exactly inspiration and expiration takes place with the help of contraction and relaxation of these respiratory muscle. So that is all about the mechanism or process of breathing or respiration. I hope this video is useful. If you like this video, please hit the like button and subscribe to my channel. Thank you.